optical compressors. Maybe you think of the LA2A, or maybe something more esoteric, like specific optocells from particular manufacturing periods. Regardless, we probably all have some idea what's special about optical compressors in our own perceptive way, and maybe you know a bit about them, or only just a little. So I hope to offer some information useful in both cases. If you know anything about the internal components, then you probably at least have some idea about this optocell thing. But a quick overview. LDR, light-dependent resistor, or photoresistor, as the name implies, is a resistor that reacts or responds to light. As light hits the surface of the LDR, the resistance drops, allowing more voltage and current to flow or pass. And how this works is due to its design in 3 sections or bands: the valence band, the conduction band, and this band gap. The chemical compound of the valence band allows the electrons to get excited when light photons hit them, so excited they can hop over this band gap into the conduction band. And as the number of electrons in the conduction band increases, the conductivity through the LDR also increases. And its response to light intensity is not linear and can vary based on the material, but is something like this. And there's a general idea that more logarithmic or exponential type shapes sound more pleasing when dealing with audio. It aligns with our perception of audio. And in a compressor, allows for the soft knee characteristic. Now, maybe you're wondering how this will work. If conductivity, current, and voltage increase with light intensity, isn't this the opposite behavior that we would want for a compressor? And in short, yes, it is. So we would generally use this to control the flow of the maximum gain reduction into the signal, like a gate or hose. And this is all well and good, but there's another critical component in all this: the light source. Since this is the thing the LDR is responding to. A similar principle, like in the video on transformer hysteresis, when we convert an audio signal into light energy, the light emitting source lags behind to some degree, as it takes time to charge and discharge. And this will give us some kind of natural smoothing, like a complex RMS window for fast onset and slow finish of release, and vice versa for the attack. And that behavior, coupled with the LDR's nonlinear response, ends up giving us some complex and oftentimes musical sounding compression. And as you might expect, the type of lamp used can also impact the sound greatly, with maybe the most stark example being the differences between the discrete designs of the past with filament bulbs and the current single package optocouplers, traditionally with LED lamps, where the response can be much more precise and linear due to its much faster ability to charge and discharge. And this was a big consideration with the design of MiniOPT+. It gives you the ability to switch between both types of designs without losing any of the other settings. Be sure to check out MiniOPT and all the mini compressors in the bundle, and take advantage of the time-limited pricing.